And one insect has taken that to the extreme, twisting its venom for a diabolical purpose that's like something out of science fiction, turning another animal into a zombie. These are the emerald jewel wasps. In this lab at the University of California, Riverside, researchers want to know how the wasp's chemical arsenal evolved to completely control her host.
So I first became fascinated with venoms because they represent a kind of chemical warfare.
Jewel wasps are parasitoids. They paralyze their prey so their offspring can live off them. After decades of research, scientists are beginning to understand the secrets of parasitoid venom. Females do battle with a host who is plentiful, widely available, and 6 times her size. The American cockroach. Researcher Chris Banks has devised an ingenious method to experiment with the wasp's venomous attack.
We're going to put a wasp and a cockroach into this area right here and let them interact. We've also included glass vials here, and these will serve as makeshift burrows for the wasp.
An unsuspecting host is first introduced to the arena. The roach is unaccustomed to threats from smaller animals. The stage for the battle is set, and the wasp is released. As soon as the jewel wasp senses a host, she will surprise her prey and use that brief moment to her advantage. She attacks. The wasp's first sting is brilliantly strategic, just enough to disarm the roach.
The first time it stings it into the central nervous system and causes a temporary paralysis of the front legs.
Venom hits the roach's nervous system in between its front legs, briefly paralyzing them.
This allows the wasps to do a second, much more precise sting into the brain.
The wasp twists its body around the roach so it can sting into its brain and inject the zombifying mixture. The roach's breathing slows. It makes no move to escape.
This brain sting causes a dramatic behavioral change in the cockroach, basically turning it into a zombie.
Wasp venom is precisely engineered to shut down signals carried by a key brain chemical called dopamine. In humans and other animals, dopamine is a naturally occurring chemical messenger in the brain. It regulates movement and sensation. With its dopamine knocked out, the roach cannot move freely or escape. Millions of years of evolution have refined this wasp's ability to hit her target and disrupt dopamine with the precision of microscopic brain surgery. This remarkable skill isn't learned, it's inherited, hardwired into each wasp. They are natural-born neurosurgeons. To regain some of the energy the wasp has lost through her stings, she clips the ends of the roach antennae and takes a drink of roach blood. Refueled, the wasp leads her zombie cargo to a burrow. But if the wasp can target her venom so well, why doesn't she simply deliver a death blow?
Venom is used for defense, venom is used for feeding, but parasitoids use it for something totally different. They actually use it for reproduction.
Inside the burrow, the wasp lays her egg on the roach. With survival of her offspring at stake, the wasp's precision now makes sense. Her young depend on the perfect execution of her sting. Now the wasp barricades the defenseless roach inside the burrow. For more than a week, the wasp venom continues to keep the roach calm and complacent, even as the newly hatched larva starts to eat it alive.
From that single egg, a larvae hatches, and after 3 days, it drills a hole in the leg of the cockroach and gets its nutrition from the blood system of the still zombified cockroach.
And now for natural selection's test. Too little or poorly aimed venom, and the roach could escape. Too much venom, and it would immediately die, destroying the wasp offspring's fresh food source.
Here we see the larva actually starting to burrow into the cockroach itself. It will crawl inside and continue to feed off of the internal organs of the cockroach. After another couple of days, it will enter a cocoon.
If all goes according to plan, 6 weeks from the first sting, a new adult jewel wasp emerges from the hollowed-out dead roach. The new wasp is ready to carry on its vicious legacy. If she's a female, her venom is ready to provide for a new generation.
The wasp is a very specific hunter. It only hunts cockroaches, and only cockroaches of this species. So every wasp that was born from a pupa that emerged from a dead cockroach had a mother that knew exactly what she was doing. So in a way, the wasps are getting better and better and better at this. The only way the wasp can subdue a cockroach is because it knows its prey so well, and it can inject the venom right where it needs to go and have exactly the effect the wasp needs.
Venom is so precise and powerful, it appears to be unbeatable. But some victims of this weapon are starting to turn the tables, evolving their own chemical answer to venom. The venom of a rattlesnake is so powerful, it could kill a human. This should spell certain death for the snake's smaller prey. But one intrepid animal has shown it can absorb a full-on strike and survive. How is it possible that a pint-sized mammal can defeat venom? In the forests and foothills of Northern California, 2 scientists, Don Owings and Dick Koss, have ringside seats to this extraordinary encounter as a deadly predator is about to be confronted. In one corner, the California ground squirrel, and in the other, its nemesis, the northern Pacific rattlesnake.
Here, take this noose. There we go. Now, get him. Whoa, 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 whoa. Easy. Oh, okay.
Squirrels are these snakes' #1 target, and these are their favorite kind, the pups, tucked away in their underground burrows.
These snakes do eat a lot of ground squirrel babies. We were watching a poor mom with babies, and she had 2 different entrances to her burrow, and there was a rattlesnake at each one of them. And she was battling to get past them so she could get her babies out and transfer them to another burrow system. After she had transferred several pups, a 3rd rattlesnake arrived at this new burrow system where she was moving her pups to.
Ground squirrels should be very afraid, but some of them have learned to fight back.
You're seeing these squirrels that are really brave and go up to a rattlesnake being bitten and then it's continuing to fight.
Owings and Koss wanted to maximize their chances of seeing snake-squirrel encounters up close. They found an area loaded with squirrel burrows and positioned a rattlesnake right in the heart of it.
Now this guy is tethered, he can't go anywhere, but he behaves in a way that is as natural as you can hope. And the squirrels will find him very attractive, and they should be popping up out of these burrows right over here. And we should get some action pretty quickly.
At mid-morning, the squirrels emerge from their burrows to find food. Little do they realize, their main predator is within striking distance. All the while, the scientists film the encounter.
Okay, he's coming in from the right.
All right, I'm moving up.
All right, can you get him over there? And you can see the snake's moving a little bit.
And I've got him in view.
Suddenly, a squirrel spies the snake. The squirrels go on high alert. Astonishingly, they don't flee. They stand their ground and then move toward the snake.
When a squirrel first spots a rattler, it stares intensely at it. And then very often it initiates an approach. Typically that includes pauses with tail flagging until it gets very close to the snake. Then sometimes it extends its body toward the snake, begins to investigate it, circles around the snake, sometimes tries to get to the tail region to take a bite out of the tail.
When the scientists first saw this behavior, they were perplexed. The squirrel's actions seemed suicidal. Rattlesnakes are armed with enough venom to kill a creature 10 times their size.
Well, this is very spectacular because it's totally unexpected that a small rodent would actually try to confront a snake that wants to eat it.
The scientists even managed to film the ultimate act of squirrel bravado, taking a rattlesnake strike. And it's not the first time they've seen this.
Another interaction we happened upon was a mother confronting a rattlesnake who was hunting her babies. She got close enough to take a hit from the snake. It clearly hurt. She backed off, groomed vigorously. Still in pain, obviously, she hobbled back over to continue to confront the snake.
Time and again, they've seen these intrepid rodents absorb venom that could kill a human. So why weren't the squirrels dying?
It made me unbelievably tense, waiting for the lethal bite to be delivered, but it never came. The bites came, but they weren't lethal.
Since it's almost as if the squirrels are running around with a shield against the venom itself.
The two researchers began to wonder if they might be witnessing something remarkable. Some ground squirrels seem to have developed their own internal anti-venom. Had they evolved resistance? Their colleague, Jim Biardi, took up the case. To find out if ground squirrels had somehow evolved a defense against this venom, he first needed to test their blood. He carefully anesthetized hundreds of squirrels and harmlessly extracted some of their blood.
I'm going to draw the blood sample directly from the heart, and this will ensure that I can get a large sample, but at the same time, the heart is so muscular that it will seal immediately after I withdraw the syringe.
Biardi isolated the plasma, the clear portion of the squirrel's blood. He ran it through a machine to test whether any part of it could withstand a blast of rattler venom.
In each one of these wells, I can put a mixture of snake venom and the squirrel blood plasma, and then see how much activity of the venom remains. The color code indicates the level of activity of the venom in the presence of the squirrel blood plasma, with blue being very low activity and red being very high activity.
Each of the 6 top squares represents a different part of the squirrel's blood. The red square indicates a portion that offers no resistance to the rattler's venom. But the blue square shows a part that shields the squirrel from its toxic effects, allowing these animals to absorb a full strike and survive. Over millions of years, the squirrels really have evolved resistance to rattlesnake venom. This explains why ground squirrels can be so brazen. If squirrels have found an answer to rattlesnake venom, it might appear useless for the snakes to pursue them. But there's one group of squirrels that is still vulnerable: the pups.
Adult ground squirrels are able to withstand the full venom dose of a mature rattlesnake, but younger animals don't have a sufficient blood volume to fully neutralize the venom.
These adult squirrels have evolved a way to thwart their predator, but the war is far from over. There's evidence the rattlesnake's venom is getting stronger.
That the squirrels have developed resistance has also put a strong source of natural selection on the snakes to evolve more toxic venom. And you have an arms race forming. As venom becomes more toxic, squirrels develop better resistance. And so you end up with these snakes which are incredibly toxic, much more than would normally have to be for a typical rodent prey.